Okay, pre-calc section 4.7a. This is the last section in chapter 4. Unfortunately, there's 3 different pieces to it, A, B, and C. So here's A. I think it'll be short and sweet. A little bit of a review here to geometry with law of sines, if you remember that. So let's just get into it. All right, so let's talk about oblique triangles. Oblique triangles are triangles that are not right triangles. So we've been dealing with right triangles with all of our trigonometric functions. That's where we usually see them in geometry. So oblique triangles are ones that are not right triangles. So we can use the law of sines, can be used to solve an oblique triangle. If you know a couple things, though, you need to know the 2 angles and a non-included side. That would be your angle side. The 2 angles and non-included side. Or 2 angles and the included side. That means the side in between those 2 angles. Or 2 sides and a non-included angle. So side angle. So all of those, if you remember, all of those. All right, so law of sines here. Basically, we have sides A, B, and C. We represent with small letters, lowercase letters. Angles are represented with capital letters. We can say the law of sines is this. Sine of A over A equals sine of B over B, which also equals sine of C over C. Now, usually you're only going to use 2 of them at a time. You just use like this 2 as a ratio here and then cross multiply and solve, or maybe you would use these 2 here, okay? Or you could use A and C, but you get the picture. Again, just want to point out a couple things that just to make sure reminders that we know that our angle is capital letters and the side opposite that angle is the corresponding side, lowercase b. So big B, little b, capital C, lowercase c are opposite of those. Okay, so let's get into it. Let's solve each triangle. So solving, remember, means we're going to have to find all sides and all angles here. So when we do that, I'm just going to kind of make a little chart down here with all my angles, angle R, angle S, angle T, and then I'm also going to have my side lengths down here so I can put them in there. Now, I'm just going to write the given information in. I know that angle R is 63 degrees. That was given to me. I know angle S is 51 degrees. That was given to me. Angle T, I don't know. And I also know that side R is 13. That's the given information. So really I need 3 things. Well, the first thing I can do is find that angle. So remember, all triangles equal 180 degrees. So I can find angle T by just subtracting the other angles. Doing that, and that gives me 66 degrees for angle T. So now I'm all set to go. Now that I have all the angles, I can find the missing sides by using the law of sines. Okay, so the big key here is just what do you have both of, right? So I have angle R, I also have side R, so that's kind of where I want to start with the law of sines. I want to go sine of R over R equals the sine of S over little s, okay? And I'll do it again to find T, but let's plug in the values we know. So the sine of R is 63, so the sine of 63, let's put a little box here so we don't interfere. Sine of 63 over side R is 13. Sine of S, I know the angle is 51, and little s is the unknown, okay? So now it's a ratio, I cross multiply. So I'll show you that here, S times the sine of 63 equals 13 times the sine of 51. And then I got to solve for side C here. So basically, I'm just dividing by the sine of 63 on both sides. Now, you'll see that you can kind of go from this step right here and solve it all on your calculator. I'm just showing you one time how to do that. So when you calculate that out, S would be equal to about 11.3. So I can put that in here, 11.3. All right, for T, it's the same basic idea, right? So for T, I'm going to go sine. I'm going to use R again because why not? Okay, so I can go sine of R over R equals the sine of T over T. I could use S now if I wanted to because I have all of that information, but why not just keep going here? So sine of 63 over 13. I know angle T is 66 now because we found that. So sine of 66 over T. And then again, cross multiplying and solving would give me T equal to 13.3 to the nearest 10th. And I would have my triangle solved. Okay, so let's go ahead and do that on 1B. Okay, and I think you guys, you know what? I'm going to let you guys complete this one because I think you guys kind of got the idea. And I think to speed through it, you could do this one on your own. Okay. There's nothing new. Find the angle K, find that angle, and then you can use, I would start with J because J, you have the side and the angle. So you use sine of J over J and see what you get there. Okay? All right. Let's talk area of a triangle given side, angle, side. So when we were growing up, we knew a triangle was 1/2 base times height, right? Triangle area was 1/2 base times height. So in this triangle here, we'd have our base here, but then we had to find a height. Remember, it had to be perpendicular to get our height. Well, now that's another reason we can use the law of sines is that I don't need to find that height if I know law of sines. So what I can do is I can use, not necessarily the law of sines, but I can just use the sine of these angles. So here's your area formulas for the triangle if you have certain sides, whatever you're given, okay? Just notice the big difference here is there's 3 different equations based on the sides you have and the angle you have. So whatever's given to you. Notice that if you're given angle A, then you would look at the sides, the opposite sides, the other sides B and C, not the opposite sides, the sides not opposite from A, sides B and C. And again, if you look at B, then we'd be dealing with A and C for the sides. C, you'd be dealing with A and B. So it just depends on what's given to you. Okay? So it's an easy way to find the area of a triangle. Another one, and this is if it's side, angle, side, right? So we've got a side, 2 sides, and an angle in between them. So we just have to pick what formula works the best. Okay? There's another one that works here on the next side, area of a triangle when 2 angles and 1 side are given. So if we're given this angle, angle, side, we can use this formula here. Area equals C squared times the sine of A times the sine of B over 2 times C, or 2 times the sine of C. Okay? So a lot to spit out there. However, again, just kind of keep these straight because these can also work as well, just depending on your variables and what you have. But again, just want to point out a couple of the consistencies. Whatever side you have would go there, and then its angle goes in the denominator. And then you can see the other 2 are on the numerator. So here we have side B, so we'd square B, and angle B, we'd take the sine of in the denominator. Same thing here with A, the side A being squared on the top, and angle A on the bottom. Because remember, we only have 1 side in angle, angle, side. All right, so let's find these areas based on what we know. So find the area of the triangle. So what do we have here? We're given a side right here. We're given a side right here, and we're given an angle. So we kind of have a side, an angle, and a side. So this is side, angle, side. So I'm going to use the side, angle, side formula and say, okay, what do I have? I have triangle A, B, and C. Well, I'm given side B, right? This is B, and I'm given side C, because this would be here. So I'm going to kind of use those. I'm given the side, and I'm given angle A. So when I do the formula, I'm going to use this one. A equals 1/2. B and C are given to me, and then the sine of A. So when we plug in the numbers, I've got 1/2. Side B is 20. Side C is 25. And then we've got the sine of angle A, which is the sine of 25. And I can calculate that all out, and you should get around 105.7 yards squared. Don't forget to square it, because remember, you're dealing with area. Okay, so let's do one more. This time they don't give us a diagram, they just give us the picture we got to deal with here. Okay, so, or they just give us some dimensions. So we can always draw a triangle. It's not that hard to do. So find the area of triangle MNP, and then it give us this. N is 14 feet, and you got a couple angles here. So let's just draw this out. And I'm just going to draw a normal triangle. It doesn't really matter. Okay, I'm going to say this is M, this is N, and this is P. That kind of matters when we go orientation. You kind of have to go around in order alphabetically. All right, so what do we know? We know that it is side N would be down here, would be 14 feet. Remember, opposite of angle N. And we're given that P is 110 degrees and angle N is 25 degrees. We don't know what angle M is right now, but we can figure that out really quick, and it would help us because we need all the angles to use this. Why? Because this one is, what do we have? We have an angle, and we have a side. So this would be angle, angle, side formula that we're trying to use. Okay? So let's do it. To do this, we need, so N is the side that I have. It's the only side I have, so I'm going to use N squared. And then that means that I'm going to take the sine of the other two angles, sine of N, M, and sine of P, and divide it by 2 times the sine of N. Okay? But in order to use this, I need all three angles, because you can see right here, I've got M, P, and N, so I need to find all three angles. Well, I can do that. That's not a problem. Okay? Because I can find angle M really easy by saying 180 degrees. And we figure out that it's 45 degrees here. Now I can plug in all the things I know. I know that N is 14 squared times the sine of M is 45, since we found that out, times the sine of P, which is 110, all over 2 times the sine of 25. And I can calculate that all out, and you'll get an area of about 154.1 feet squared. Okie dokie. That is it for part A. Like I said, short and sweet. What did that take us to? 13 minutes. Woo! How about that? All right, we'll see you guys tomorrow or the next day, whenever I see you.